Right, we solve linear equations by making sure whatever happens on the left-hand side also happens on the right-hand side. That keeps the two sides equal. So whatever we do will be the inverse operation, will be the opposite. So if we're multiplying something on the left-hand side and we want to peel that away, we do it to both sides, sometimes called backtracking. And you can substitute back into the equation to check that it worked. I'll show you. So with each of these, what's happening to x? X is being multiplied by 2, and then we're adding 3, and that should give us 4. So to work it out, I don't want to divide by 2 right away because that'll also affect the 3 and give me another problem. So let's peel away the positive 3 by making it negative 3, or taking 3 away. I'm adding 3, I'm taking 3 away. That leaves us just with 2x. 4 minus 3 is 1. And now I've got 2x, which means 2 times x. So I divide by 2, and that gives me x equals 1/2. And so if I go back and check, and I substitute 2 times 1/2 plus 3 equals 4, well, 2 over 2 is going to be equal to 1, and 1 plus 3 equals 4. It works. Equator. So this one over here, again, I don't want to multiply by 4 right away because that's going to just cause me a hassle, and it could lead to inaccuracy. So I'm taking away 3 on this side, so let's add 3 to both sides, which gives us 10 and leaves us with just x divided by 4. And now if I want to have x by itself, x is being divided into 4, let's multiply by 4 on both sides. And that gives me 40. X is equal to 40. If I want to check it, I go back up and I would put 40 over 4. 40 divided by 4 gives me 10. 10 minus 3 is 7. It works. It's okay. Now this one, I've got 5, and there's a positive in front of that 5, isn't there? Yes. So in order to strip that 5 away, I'm going to do the opposite, and I'm going to subtract 5, always from both sides. And on this side, it's going to give me 7, isn't it? And be careful here. You're left with negative 2x, because you've got to keep that sign there. You are taking away 2x. You need to continue to do that. And now the quickest and bestest way to get rid of anything that's happening to x is to multiply it when it's next to it. So we're going to divide by, we're going to keep that negative. So we get positive x and divide by negative 2. And the best answer we have is negative 7 over 2, or that negative sign could be right in front of. I'll also write it like that. Another way to write it is this means the same thing. Negative 7, it's right on the line, over 2. And I'll leave you to go back and check that and see if it works. This one over here, same kind of bizzo. 2 x's. I don't want to. 2 x's are divided by 3, and to whatever that is, we add 5, I don't know, chickens, whatever they are. So what do we do first? We don't want to multiply by 3 right away because that'll get us into trouble. It doesn't involve the 5. So we're going to take away the 5, take away the 5. That still leaves us with 2 x's being divided by 3, but on this side, 7 minus 5 is 2, isn't it? Yeah. And then now we've got 2 x's being divided by 3, so we'll do the opposite on both sides. Is 6, and then you can probably see where we're going with this. If we divide by 2, 2 divided by 2 is 1x, which is what that is, and 6 divided by 2 is 3. So x equals 3. If I were to substitute back in here, 2 times 3 is 6, divided by 3 is 2 plus 5 is 7. So she works. Now this one, yay! We finally got one where 2x has 4 added to it, and that whole lot is being divided by 9. And so we want to get the left-hand side to equal the right-hand side, which equals 2. So in this case, everything on top is being divided by 9, so we can multiply by 9 to give us just that 2x plus 4, which is a lot easier to deal with. But we've got to make sure that we also multiply by 9 on this side, which will give us 18. To this 2x, I have 4 added, so I'm going to take them away to get just 2x. Take it away on both sides, and that gives us, what, 14? And then in the end, if I've got 2 x's, I divide them in 2, and I only get 1x, and I divide this in 2, and I get 7. That's it.